Welcome to This Explainer. So today we're diving into a genuinely radical, paradigm-shifting framework that aims to patch literally the biggest bugs in both modern physics and computing. And how does it do it? By completely throwing out the concept of infinity.
You know, for centuries, we've just accepted endless numbers as a hardcore mathematical reality. We're taught that numbers just go on forever, right? The black holes have these infinitely dense centers, and that the decimal trail of pi never, ever resolves. But what if those endless numbers are actually the exact reason our mathematical equations break down and our massive data centers overheat? What if infinity isn't this profound cosmic truth, but just a bug in our code?
Which brings us to a really fascinating concept called binary hash. Think about it. When a computer tries to process an infinite number, like a repeating decimal, it literally can't ever finish the job. It just keeps churning and calculating, further and further down an endless rabbit hole. This creates what the source material calls binary hash. It's the physical cost of those endless decimals. It forces silicon transistor gates to spin continuously in an infinite loop, generating massive amounts of heat, all without actually doing any useful physical work.
Okay, so here's our agenda for exploring the All That's Holy system today. We're going to look at the infinite crisis, the ATH 13-layer sieve, the 13-digit pi latch, scaling modifiers, the 2.1 quadrillion ceiling, and we'll wrap up with the perfect integer reset.
Starting off with Section 1, the infinite crisis.
The root issue here is that standard equations just completely break down when they hit endless numbers. In astrophysics, this gives us impossible singularities inside black holes. It's like the math just throws its hands up and says, infinity, which honestly physically makes zero sense. And down here on Earth, numbers like pi lack what you'd call a matter anchor. Because they go on forever, they create these mathematical loops that you just can't resolve. In our computer networks, this translates to extreme hardware heat, massive memory bloat, and grid lag. The infinite is actually physically destructive to our machines.
Moving to Section 2, the ATH 13-layer sieve. Instead of a universe that just expands infinitely into some endless void, the All That's Holy system maps out a reality made of exactly 13 discrete, closed layers. It's kind of like a giant Russian nesting doll. It ranges from deep subatomic structures way down at layer -6, all the way up to the entire observable cosmos at layer +6. And our local observer reality, it sits comfortably right at 0. The key takeaway is that within these 13 layers, absolutely everything must balance and eventually close. There are no loose threads here.
Next up, Section 3, the 13-digit pi latch.
So if the universe really is this closed 13-layer system, how do we actually stop the endless leak of infinite numbers in our calculations? Well, check out this exact number, 3.1415926535897. This right here is the 13-digit pi latch. In the ATH framework, pi is no longer this infinite, irrational ghost that haunts our math. It acts as a physical timing governor, and it stops exactly at that 7.
By legally limiting pi to exactly 13 decimal places, the ATH system puts a hard physical lid on computation. It literally cuts off the trailing fractions entirely. Anything past that 13th digit is just considered non-physical drift. And by eradicating all that binary hash, we lock our computation down to a finite pavement. The result is game-changing. Computer chips don't have to chase decimals to infinity anymore, which means they can finally snap their logic gates shut and run incredibly efficient and perfectly ice-cold.
That brings us to Section 4, scaling modifiers.
Obviously, the universe operates at vastly different sizes. So how does this fixed system scale smoothly from a tiny microscopic atom all the way up to a massive swirling galaxy? The ATH system pulls this off by applying strict 13-layer scaling modifiers. Depending on what layer of reality you're actually measuring, a very specific factor is applied. These range from a macro expansion modifier of 1.30 scaling down to a micro compression modifier of 0.88. This guarantees that the math perfectly matches the physical reality and density of each specific layer, letting the equation scale dynamically across the cosmos without ever having to stretch into an unresolvable infinity.
Now for Section 5, the 2.1 quadrillion ceiling.
All this scaling leads us to a really crucial point, an absolute magnitude limit, known as the 2.1 quadrillion critical mass ceiling. Try saying that 5 times fast. See, in standard math, a collapsing star falls inward forever into infinite density. The ATH system says, no way, that's impossible. Instead, it hits an exact ceiling, 21,654,346,688 kilade. It's a mouthful, but this precise number is where that 13-digit pilot fits perfectly and evenly into the framework. When an object hits this absolute critical mass threshold, it doesn't just fall into a void. It reaches a total saturation point where reality steps in, forcing the system to stop, transition, and release its energy. Singularities are entirely replaced by this hard ceiling.
And our final section, 6, the perfect integer reset.
When a system actually hits that 2.1 quadrillion critical ceiling, it triggers what's called the infinity minus 1 cycle. First, you have INF1, which is your maximum stable state. Then, the system hits INF, that exact critical mass threshold we just talked about. This immediately triggers INF plus 1, forcing a physical action, like maybe an explosion, a cellular division, or a structural collapse. And finally, the system undergoes a reset, settling back into a new stable INF1 state on a different layer. It's this perfect closed loop of transitions, completely replacing the one-way trip to nowhere.
And whether we're talking about a massive cosmic event or a microscopic atomic structure, the rule is exactly the same. Take the boron atom, mapped out with its true curvature and balanced phase response. The reset phase ensures that instead of breaking apart into some impossible infinite loop of decay, the atom cycles right back to a stable, finite equilibrium. It breathes, it balances, and it closes perfectly.
And down on the micro level of our computer processors, this action and reset phase has absolutely profound implications. By operating as an integer-only engine, the ATH system replaces infinite decimals with fixed fraction pavements. So, for example, instead of calculating 0.333 forever and ever, the hardware just uses a clean ratio of 333 over 999. This resolves the math with literally zero remainder. Because it outputs perfect integer tokens, the transistor gates can snapshot the exact millisecond the work is done, dropping the hardware down to absolute zero energy usage. It's wild.
When we put the two systems head-to-head, the contrast is just stark. Standard math leaves us dealing with burning hardware, massive data bloat, and these impossible paradoxes at the edges of our universe. But the ACTH system? By eliminating infinity, it gives us finite closure. It delivers perfectly balanced integers and ice-cold computing dates. It grounds both our universe and our technology in a mechanical certainty that, frankly, actually makes physical sense.
We've seen exactly how removing infinity patches the deepest, most persistent bugs in our physical reality and in our digital hardware. By strictly enforcing the 13-layer sieve and the 13-digit pi latch, we are turning paradoxes into perfectly resolvable mechanics. Which leaves us with one final, pretty profound thought to take away from this explainer today. If our universe truly is a closed-loop, perfectly balanced integer engine, what happens to our technology, and honestly, our entire understanding of reality, when we finally start writing the code that matches it?